Those who will not be able to join, they can pick it. Thank you. So we proceed.
All right. Thank you very much, and good evening or good afternoon to everyone. So we are going to continue from where we ended on Wednesday. On Wednesday, we were at this very point where we are looking at some of the naming conventions when it comes to we working with Python. I think the last thing we discovered or we discussed was the rule that says we shouldn't be using variable names, or sorry, we shouldn't be using keywords for our variable names. Now, let me emphasize on the point that we are definitely going to use keywords, but definitely not for our variable names. So let me uncomment this back. And we just wanted to have a feel of what these keywords are. So this is something we are going to deal with much later on. But in order to see those keywords, we needed to do some importation and then get to see the reserved keywords. So I'll run this and then this is a list of the keywords over here. So for instance, yes, we are going to use false, we are going to use all the things you see over here, but then we are not going to use them as a variable name. So for instance, you've seen something like first name, and then I've done an assignment in the past. So let's say Kwame. This one is looking good. And we've seen something like maybe course, and then maybe the course is maybe machine learning. Now, these are variable names that conforms to the rules we stated much earlier. They are descriptive enough. Then, in fact, with this particular one, there are no white spaces. So everything looks pretty much okay. Now, what we want to do is, in relation to the reserved keywords, look at this. We are saying that words like the ones we see over here, false. We cannot say false is equal to, let's say, answer. Okay. Even if we want to say this, we have to say it in a different way. We cannot say, for instance, true is equal to something because the moment we put it first, that means we are using it as a variable name. We cannot say none, or none is going to be equal to something. All right. Now, there's some trend going on over here. You could clearly see that for the reserved keywords, whenever we type them, their colors look a little bit different. They are colored in blue. Okay. But then with the other variable name, they look okay. At least they are colored in black. So we cannot chew and pour all these reserved keywords in our head. But in the event where we are even using one, at least we'll be prompted looking at these colors. Now, oh, this is probably a reserved keyword. So you cannot use them. So that's basically the point we are trying to make over here. Now that we know that we cannot use these reserved keywords, at least for our variable names, we are going to use them. And some of the things we are going to learn later on is going to help us understand that. Now, the next point we have over here is we cannot use, or Python is case sensitive. So let me use this particular example to explain this point. The case sensitivity over here basically deals with it being uppercase and then lowercase. So for instance, if I'm to say age is equal to 12, this age is equal to 12 is definitely different from this age is equal to maybe 20. Because the age I have on line 30 is in all lowercase, but then the age I have on line 31, the A is in uppercase. And for that reason, the value we have over here, or the variable we have declared on line 30, is definitely different from the variable we have declared on line 31. Now, because of this case sensitivity, let me also explain a point over here because look, if I have age is equal to 12, and then I'm using the same variable, age, and this time around, I'm saying is equal to 90. And I come down here to print the value of age. The question I want to ask is, what do you think is going to be, or what do you think is the value of age as and when I'm printing it on line 33? Who can share his or her opinion on the value of age as at this point?
Yeah, I think it will be 90.
Okay. So my brother is saying it will be 90. And this is also some of the things you are going to learn later on. But then let me just quickly bring this up over here so that when we get there, we just brush over it because we are practically learning the same thing. Now, what happened is we know that the order of execution, in that the first piece of logic will execute before the second piece, and in that order. That's the default way of how things are done over here. And then we are seeing that at least line 30 comes before line 31. So indeed, at the first instance, age, the container age or the container with the label age is going to have the content as 12. But then we change things over here. So this is one of the key characteristics of Python, which you're also going to understand that Python is dynamic. So this is one of the dynamic nature in that if we use the same variable name and then change things up, definitely things are going to change. So over here, when I run this, you will see that, let me comment this one out so that the keywords don't print out. So when I run this, I get 90 showing up over here. All right. If I take this one out, then I'm getting 12. But then when I bring it back, sorry, when I bring it back, we are getting 90. It is similar to something over here. Let me just use this example. So for instance, let me just open up maybe Notepad, okay? And inside of this, let me save the value 12. Remember, this 12 is the value we are saving in a container called age. And then let me save this. So I'm going to save this and then save as. I'll navigate through this and put it on my desktop. But the label or the name I'm giving this is age, small letter age, and then I'll save this. So I'll close this. And this is on my desktop. So if I'm to come to my desktop, at least I'm going to see that container with the label age. And when I open inside, I'm getting the value 12 over here. This is almost like what we have done in terms of code implementation. All right. Now, if I'm to come back here and then open Notepad again, this time around, I'm trying to replicate what I have on line 31. So line 31, line 31. I'm putting the value 90 over there. And I've come in here, save as, and then I'm still on my desktop and I'm saving it using the same variable name age. Clearly, when I run this and save this, it is asking me, look, you already have a file with that name. You want to replace it, you want to overwrite it. If I say yes, then indeed that happens. So this time around, same container with the same variable name. When I open it up, I definitely see 90 over here. So what is happening here in terms of computer programming terms, it's nothing different from what I just illustrated. So over here, there's an override. There's an override of the data, but then we are having the same variable name. Now, if, for instance, this was capital letter H, then these are two complete containers altogether. And in this way, if I run this, the value of H, small letter H for that matter, is 12, because this is not an override. This is just a different variable name. And that's why you're seeing that the case sensitivity of Python is being amplified over here. And in this case, if I'm to do a printing of capital letter H, this is where we now get to see the 90. All right. Now, the next point we have over here is one of the final rules we have over here. Then we'll move on to something interesting. Now, the final rule we are saying is, look, there's an almighty rule. And this almighty rule is something I came up with based on some experience I had back in secondary school. Because back in secondary school, we had, the the prospectus, the student handbook. So you know the rules and then the appropriate sanctions if you break them. And back then, I was a little bit careful because I know some of the rules, if you break them, you go home or you'll be demonetized. Some of them, you'll be sacked. And some of them, when you break them, you just take some internal punishment within the premises of the school. And as many rules as there was in our students' handbook, the rules definitely were not exhaustive. I mean, you cannot possibly think of every possible offense that students may break. So, for instance, there was the Almighty Rule, and that Almighty Rule is that any breach of common sense is a breach of school rule. So that was quite descriptive in the sense that, look, it may not be specifically or explicitly written that, sorry to use this example, when you go and maybe urinate in front of the housemaster's house, then this is the appropriate sanction. But then indeed, that will be captured under the breaking of common sense, okay? Any breach of common sense. So the almighty rule we are trying to apply over here in terms of naming our variables. Look, if you are breaching common sense in terms of naming things, then you are probably not doing it right. So you should go back to trying to find names that are descriptive, trying to describe the data you are storing in there, trying to make sure that you are not having white spaces. You can use the underscore or the camel case notation. You're also trying to make sure that the numbers are not certain, are variable names, but then you have numbers anywhere within the name. And we cannot use, for instance, reserved keywords. Even if we don't know where we attempt to use one, we'll have a prompt where, for instance, if I try using, let's say, false, you get to see that this is colored in a certain way. If I try to use true, which is a reserved keyword, it's colored in a certain way. However, I can use, for instance, false, and this small letter false is definitely different from the capital letter false I see on line 35 because of the case sensitivity that we just spoke about. So these are the rules we just have to, we don't have to do this true and poor. Just apply common sense in your naming convention and then you'll be fine. Now, having said that, let's look at what we have over here, where we are looking at multiple assignments, or the technical word we use over here is unpacking. So when I'm to do x is equal to 5, remember what we said earlier on, that look, we have a variable or a container with a label x, and in there we are putting the value 5 in there. And we said this single equal to is what we call or refer to as the assignment operator. It is almost like a funnel where we are using that as a link between the container we are pouring that data in there. All right. Now, if it is this way, then it's like a single assignment. Then I can do maybe y is equal to 10. This is also an assignment of its own. Now, if I'm to come in here and do a printing of x, when I run this, the content that I have in x is indeed the 5 I have over here. And then if I'm to do a printing of y, and I run this, I get to see 10 over here. Now, what I have on line 38 and 39, I can put this on one line, and this is where we refer to as the multiple assignment. So what I can do is I can do x, y is equal to 5, 10. What I have on line 38 and 39, I've consolidated everything. I've merged everything into a single line. Now, usually, I do encourage students to do this, but because of the things we'll be dealing with later on, especially with machine learning, we are going to see this a lot. Okay. All right. So then, if I have something like this, what it basically means is, look, the first variable will be paired up with the first value on the other end of the equal to sign. And then the second variable will be paired up with the second value on the other side of the equal to sign. So over here, nothing has changed. If I'm printing y, because y is the second value over here to be assigned the second value. So when I run this, indeed, I get to see my 10. And then when I try running this to print out x, When I run this, I get to see 5 showing up over here. So there's no problem yet. However, we may encounter some problems if there's a misproportion, okay? In that over here, we have 2 variables, and then we have 3 values. So the common sense logic is, okay, the first value will be assigned into the first variable. Then the second will go into the second variable. The big question is, what about the third? There wouldn't be any variable left for this value left behind. And it is almost like some of the basic concepts we know in chemistry, physics, and stuff like that. Okay. So I try to use these examples very often because these are things that we already know as engineers. So, for instance, that concept about the law of conservation of matter, where we know that in a chemical reaction, matter is neither created nor destroyed. Okay. Over here, let's try and call this the law of conservation of data. So in computer programming, as we have, or in variable declaration or assignment, data is neither created nor destroyed. Because if I try running this and say, I want to see X, when I run this, I get an error. And over here, you see that there's a value error. It tells me that, look, too many values to unpack. It's expected 2. And it makes sense. It makes sense because there were only 2 variables over here. And if it had gone on to indeed give this to this, and then give 10 to y, that means it is going to destroy 20, which is going to be a clear violation of that concept you are trying to bring over here, that the data can never be created nor destroyed. Okay. All right. Now, having said that, let's assume this is now going to be okay because there's going to be equilibrium over here. What about if there's Z? Then the interpretation we are going to see over here is that, look, there's going to be more variables than values. So once again, if the first value is assigned to the first variable and the second value is also assigned to the second variable, then what becomes of the third variable? There's going to be a misproportion over here. So when I run this one too, of course, there's a value error. And this one, the prompts or the error we are getting is a little bit different, but quite descriptive. It is telling us that not enough values to unpack. It expected 3, but then got only 2. So some of the errors we may see shouldn't scare us. It should rather tell us that, oh, okay, this is what we got wrong, and then this is what we should do. All right. Now, let's go back to what we have over here. So this one, there's equilibrium. We don't have any problem. But what about if indeed there's 20 over here, there's 40 over here? That means at least there should be at least 4 variables here to accommodate the 4 values we have over here. So when I run this, we get a problem. Now, if I put a star in front of the y, if I put a star in front of the y and I'm printing x, when I run this, now we don't have any problem. We get to see that, look, 5, which is the first value, has been assigned to x. Then the big question is, okay, then what becomes of the other ones over here, even though there's a misproportion, okay? And I mean, what do you think is going to happen? Let me find out from you. I mean, using your own intuition. If x has been assigned to 5, or 5 has been assigned to x, then what is going to be made of the values 10, 20, and 40? Because they cannot be destroyed based on the kind of inspiration or logic we are trying to create over here. What do you think is going to happen to these numbers that I've highlighted over here?
Hello, sir.
Yes, Sheriff, you may proceed.
So, I think since there's no problem and the language was able to print out 5, then I think the rest will be given to Y to take care of.
Okay, that's a logical thing over here. So now let's try printing Y to actually verify. And now when I print Y, indeed, we see that things have been bundled together. So the rest of what was left has now been put together as one entity, which we are going to discuss extensively in some later chapters. And everything has been bundled for Y. Now, if for some reason the star was on X, then when I run this, Y is going to take the last value over here. When I run this, Y is going to take the last value, which is 40. And then using our own intuition, definitely 5, 10, and 20 will be bundled together and then sent to the variable X. So definitely when I run this, you get to see that showing up over here. All right. Now, what about if there is Z over here? If there is Z over here, then the conversation changes a little bit, but the principle still remains, okay? The principle is the single values are going to be sorted out first. So when I say the single values, definitely these are the single ones. They are going to be sorted out first. And whatever is left will be given to the one that carries the star. So this star can also be seen as, especially for the computer engineering students, you definitely know that when you're writing SQL or SQL, and when you say select all, you don't write select all, but you say select star. So that star basically means all. So that's how maybe you can also relate to that particular thing over here. So over here, when we say star, it means all. But then the singles need to be sorted out first. So what is happening over here is Z is the last single in terms of the variable. So it will be assigned the last value in terms of the value side. And then it will move to Y. Y is the last but one. Okay. Variable. It will be assigned to the last but one value over here. And then the rest of what we see over here will be assigned to the one that carries the star, which is all. So over here, if I'm to do a printing, kindly check your microphones. So over here, if I'm to do a printing of Z, as we currently see, because it is the last over here to be assigned the last value here. So we get to see indeed, we are seeing 40 showing up over here. If I'm to do a printing of Y, and I run this, we are seeing indeed 20 over here because it's the last but one. Okay. And then finally, if I'm to do X, after assigning the singles, whatever thing which is left will now be bundled together and given to X. So when I run this, we see this over here. What about if there is a star in here? Once again, things will change a little bit, but the logic still remains. The logic is like that the singles will be sorted out first. So X over here is the first single. That means X will be assigned the first value. So when I run this, you see 5 being assigned to X. And then if I run this to print out Z, Z is the last value. So it will be assigned the last value over here. So we see 40 showing up over here. And then finally, if I'm to do Y, once the singles are sorted, what is left is what's exists in the middle. So definitely Y, we have whatever thing is left bundled together and presented to it. All right. So that brings us to the end of this chapter. And if there are any questions, you can just prompt me and then we'll find answers to that. Else, we'll move on to the next chapter, which we are going to deal with data and data types. All right. So let me touch on data and data types. Well, we couldn't have finished the conversation about variables without dealing with data. Because look, there are two sides of a coin, okay? We are saying that based on the definition that we have, that a variable is a placeholder for storing data. So if we talk about variables, we definitely also have to refer to or also discuss data. And you see me do a few things, okay? Especially from last week, where you saw me do something like maybe name, and then name, we put name in quotation marks. But then when I was doing age, I didn't put anything in quotation marks. So whatever thing we are going to learn here today is going to explain why some of the things we do, some of the data, we put them in quotation marks, and some others, we can leave them like that. All right. And that's simply because there are different data types we work with. So the data that we are storing in the variable can come in different forms. The first one we are going to discuss is what we call strings. And Python will usually refer to this as str. Now, a string, and please pay attention over here, it is a collection of characters. It is a collection of characters declared within a single or double quotation mark. So this is very important. And the emphasis is a collection of characters declared within a single or quotation mark. So if I'm to say course, and say course is equal to, and I put this in either a single, so this is a single quotation mark. So this is machine learning. Okay. What I've done is I have put the collection of these characters in a quotation mark and I'll assign it to the variable course. And we are saying that the moment I have anything in quotation mark, that then is a string. And we are going to confirm that first. But let's see other examples. Let's say we have a variable school. And this time around, I'm putting school in double quotation mark. So you see that the quotation marks are double on each flank. Okay. And then let's say this one is the school is engineering sciences. So in this particular instance, in the case of line 5, we are saying that it is a string because it is declared in a single quotation mark. And on the case of line 6, we're also saying it is a string because it is declared in a double quotation mark. Then let me also do this. Age is equal to 12. The emphasis over here is not about the content, but then is it in a double quotation mark or a single quotation mark? If the answer to that question is yes, then it is a string. It is not what it actually looks like, okay? Because what is going to happen is, look, if I'm to do a printing of the variable course, if I'm to run this, I see machine learning showing up over here. All right. If I'm to change this and print out the variable school, and then run this, I'm seeing engineering sciences. Let me zoom in a little bit. I'm seeing engineering sciences. And then if I'm to print the content of age, I'm seeing 12 showing up over here. So then we want to basically confirm the data type. And the way we confirm the data type, up until this point, one of the predominant, and this is what I say, one of the predominant vocabulary about the Python programming that we have been doing is print. We have been printing. Yes. Print, based on the explanation we got from last Wednesday, that look, it is almost serving as one of the functions, or let's say the buttons on a TV remote. So we get that point. And it gives us a unique functionality of printing things out in the terminal for us. All right. Now, in order to check the data type of a variable or anything that we are working with, we have the type keyword over here. So once again, this is also one of the vocabulary that we are also going to learn. Okay, so type. And then what do I want to check the data type? I want to check the data type of, for instance, maybe school. Now, when I have it this way, what I want to do is I want to now print it out. So I'll wrap everything up in the print function. So now, whatever thing that's going to be outputted is going to be around school, but it is going to be the data type of school. So when I run this, indeed, I get to see that the data type of school is str, which is string. Now, if I'm to change this and say, okay, I want to check the data type of course. When I run this, the data type of course is also str, as we see over here. Now, the key difference between the declaration on line 5 and then line 6, the only difference is this one is declared in a single quotation.